POWTECH Virtual Talks. And now you will listen to Guido Kammerer and Markus Kille from ATEX Explosionsschutz GmbH about the simple solution since there is explosion isolation up to 10 bar. Have fun and empower yourself enjoying the talk.
First of all, I want to say thank you for the invitation and for this improvement. Yeah, so to switch to the other platform, to Zoom, yeah, my topic is similar to Jim's. Yeah, it's also a passive isolation device. Yeah. And I've called this the simplest solution as there is an explosion isolation up to 10 bar. Yeah. But before I will start, I would like to take the opportunity to introduce myself and ATEX, because I assume most of you heard something about ATEX for sure, but didn't know that there was a company called ATEX. Yeah? This is also due to the fact that unlike other explosion protection companies on the markets, we do very little advertising, no marketing. Yeah? So our marketing is more or less the references from our customers. Yeah? But to have no misunderstanding, we did not write the ATEX directive. Yeah? We have taken this name even before the directive was introduced. But our company founder and me, we have worked in some standardizations groups for the European Union earlier or more or less from the beginning. So starting in the beginning of the 90s. On this, especially in the groups of explosion suppression, isolation, venting. But today, we, so means the ATEX company is represented by one of our employers and not anymore by Dr. Alfred or me. The ATEX company was founded in 1993, yeah, 4 years after the German reunion. Why I say after the reunion? The federal German government commissions explosion protection experts to assess the process and explosion safety of the companies in east of Germany. You can imagine that in that time, the companies in east of Germany, they have different standard than we have in the rest of Europe. Yeah? And this group of experts founded under the leadership from Dr. Alfred an engineering company and have developed explosion protection concepts, yeah, in Germany and very quickly international too. And what was new on their concept was in the beginning of the 19th, yeah, what seems quite normal today, that concept were developed that they combined various protection options. So for example, suppression with mechanical isolation or venting with chemical isolation, so in pipes. And in that time, customers not find this with manufacturers of explosion protection system in that time. So they found only suppression companies or venting companies or companies they make protection system for the maximum explosion pressure, mechanical isolation. But there were in that time no company which have or could deliver a combination of this. And because of that, Dr. Alfred founded the ATEX companies, yeah, and signed contracts in the past with several manufacturers. You know these names, for example, in the past were Kille or Rambo or whatever. So we have started in the past as a reseller. Yeah? However, the increasing success from us. Because of that, the manufacturer terminated the contracts more and more, and that makes us more and more to a manufacturer. Yeah? And today we have our own companies in Europe, North America, South America, Australia, and here you can see my mouse. Yeah. Here, this is an old military company. We moved to this company in 2008. This part we have spent to the German government for refugees. But here we are still our production and service department, and also our test field. I will talk about later more on that. The product from us, the focus was also on the operator, on the end user. All the products we have in the range today, they have low or no following costs, low maintenance costs, or it could maintain by the end user themselves. For example, here you see explosion ventings, vent panels or flameless venting. I will come back later on this. The only thing I want to say here is I would like to mention that our company founder, Dr. Alford, have developed the principle of the flameless venting while he was still working and researching at the Michelsen Institute in Norway. In the end, he developed this product with a German manufacturer, so that the patent on Dr. Alford and Bennett panel reads. Today, the patent has now expired, and you can find out a lot of systems on the market. You know this. As in many other areas, we are breaking new grounds here. We are the first manufacturer which have an online shop for vent panels. The price is transparent, independent of the quality, delivery times, and the delivery times is specified for 48 hours, and that worldwide. So it's quite new on the market. Here are some examples of explosion suppressions we have, and also here's a focus on low following costs, and the customer can refill this for themselves. And here you can see we are the only manufacturer that have explosion protection with hot water. Here inside is filled with hot water, and it's permanently heated on 180 degrees. And in case of an activation, we are triggering water or steam in it to extinguish the explosion valve. This is very interesting for wood industry. Of course, we have also mechanical isolation, the quick closing valve, and it can be used in many ways. Most important, that it cannot be destroyed after fast closing, maybe because of an explosion. You have to press just a button and it's ready for the next explosion. So there is no destroy on this. It's not activating by gas generators, only by 6 bar compressed air, which is normally on customer side. This is the only product which the ATEX company does not manufacture itself. It's made by my family company, developed from my father, and modified by me for the food and pharmaceutical industry. For example, there was a question before for the food industry, for a clean surface inside of the valve. So here we have developed a system for this valve which cleaned it permanently. So maybe this could be interesting for somebody of you. The next point is our test field. Yeah? We have a big test field. For example, we have the biggest test vessel in the world. Here it's 145 cubic meter. This is one for 25 cubic meter vessel, and many notified bodies came to us and use our test field because we have more option than they have self. Yeah, so it comes to DECRA, the INERIS, the LOM, the GEXCON, just to say a few names. Yeah, also customer builds entire system to carry out explosion tests here. So, but why we are doing this? Yeah? So this is our 25 cubic meter vessel. Yeah? Here you see a complete plan from a customer to test. Here we have tested our float valve and DN 800 for gas test. Here, this side will be filled by gas, and this also, the valve will be closed, and you make an ignition here, and the only explosion have to rise up on that side, but not on this side. I will show you, I hope this will work now. I will show you why it's important to have a test field. Why I can, okay, I hope. So, can you see this movie?
Yes, we can see it. It's okay.
Yeah, and it's running fastly, or it's yeah. So this is a normal explosion.
Please stop at the flame. It's too quick.
Yeah. So you see, it's too quick. So what you can see here is how fast an explosion, so the flames comes out. Yeah. So what could be interesting. Whoops, done a mistake. Sorry. What could be interesting when we make the same explosion with a suppression system. Yeah, I will stop this before. Yeah, this is the same vessel. Now we are creating an explosion here inside with starch. It's an ST1 dust. Yeah, and but you will see it's a suppressed explosion. Yeah, this is this is a starch powder which come out. Yeah, and then the suppression starts, and you see still we have a big pressure wave. Yeah, okay, the explosion is the vessel is protective. Yeah, with suppression system, but you have also the problem with a pressure wave. No flames comes out. Yeah. But you still have a problem with the pressure wave. You see how important it is to have an isolation there, and it could be interesting to do this with a mechanical isolation and not with a chemical one, yeah, because the mechanical will stop also the pressure wave. Yeah. What we have also tested here is flameless venting test. Yeah, I started here. We'll see. So you see, the explosion works very. The flameless venting device works very well. Yeah, see the no flames comes out, just it's condensate. Yeah, it's not dust from the inside. It's steam or what's coming out. Yeah, so it has worked very well. But what the next video I will show to you, what will happen if you have a too high dust loading. So you have some limits on flameless venting. And if you have a higher dust loading inside, or your flameless venting has also a limit in the volume, in the biggest volume you can protect it, independent of the vent area you use. Here you will see what could happen in case what could happen in case the limits is higher. So here why it's not running? Yeah. So you see, and we talk about here about a device which it's more than 1,000 kilogram. Yeah, this venting device, and it's flying. Yeah, more than 20 meters. Yeah. You see, because of that, it's very interesting to have your own test field to can check everything. Oh, sorry. No, okay. Okay, I want to go back to the application. I want to speak with you. Yeah, here the one of our customer have asked us for for a protection system. Yeah, because of a confidential reason, I've only show you this on key data. Yeah, here this could be a dryer or a mill. And this a filter or a cyclone, yeah, everything it's designed for 10 bar. Here we have no dust loading. Here comes the fresh air inside, yeah, and here we could have a dust loading. And the customer have said, according to the explosion document, we can create an explosion here in that vessel and also this vessel. In the past, these customers, yeah, have good experience on our float valve, yeah, our passive isolation device, yeah? And because of that, he wants to have the same solution. Yeah, so this was the solution he wants to have. Here we have the diameter of 800, 500, and also 800, and so. At the end, this was what the customer wants to have. A single acting valve with an explosion with the flow direction. It's here, the flow direction of that way, and the explosion will have the same direction. Here it's in the opposite. Explosion comes from here, but the flow comes from that side. And here we have a bidirectional valve. Yeah? We could have vertical positions and also horizontal positions. They could have here a high dust loading, yeah, and also pipings directly in front of the valve. This could be a different, yeah, because I'm sure that some of you are knowing a similar explosion protection valve, yeah, but this was the list what we want to do against the other solution. Yeah, we want to have no gaskets inside, yeah, that we have no temperature limits. We want to have a passive valve. Yeah, we want to have no powder monitoring. Yeah, we want to design a valve which will work. Yeah, independent of the dust loading. Yeah, and it's should be not closure from the airflow. Yeah, so for sure, same with the double acting valve. And so here you can see what we have designed. Yeah, you see here we have no gaskets in the passions. Yeah, no gaskets, which shows to the process. Yeah. So no problems with temperature or solvents inside. No problems with aging of elastomers. Yeah. The closing element, the ball, yeah, the closing element is fixed by these latching device. Yeah. It means if you have pressure wave in your pipe or different airflows, for example, when you have starting your process or because you have elbows in front or behind of the valve, we are independent of this because it's fixed. Yeah, waves cannot move these. Yeah, the ball. We have no springs here in this angle, yeah, because we have fixed this closing element with this latching device. And on this latching device here in the middle, there is a ball that is under the spring tension. Yeah? And this spring defines the air velocity, means it could be increased from 20 to 25 or 30 meters per second, and you can change this for yourself without moving the valve. So for example, you have an airflow, it's designed for 20 meters per second, but later you see your airflow in the pipe could be higher. What you have to do is to turn out these latching device, just only this, and put a new one inside. Yeah? And this is allowed from your side to do it for yourself. Yeah? Here you can see, because we have no gasket, here we have an edge here. Yeah? And that's in case we have products deposits, we will cut this. Yeah? The notified body where we have certified this for 8 years, yeah, they don't want to certify this for us at first, but now after we have installed this now for more than 8 years, after having these been successfully used for these 8 years, he has had permitted without now any limitation of the dust loading. Yeah? So the valve are always closed in an event of an explosion. So means for sure we will never say to you it's applicable for a filling line of a silo, yeah? Because it's this closing element could stuck, yeah, the product maybe when you are transporting 200 or 300 kilograms, yeah. But what we could demonstrate to the notified body, it will definitely closed. Yeah, also with these high dust loading. Yeah? Another difference to other is when you want to move these from the horizontal to a vertical position. Yeah, so you can change this very simple. Yeah, you only have to move the sketch, or I have to close. I hear this. Yeah, so so you can do, like I've said before, you can do many things for yourself without RAS. Yeah. Here you see the restrictions we have, yeah, and you can limitate this. Yeah, you can put the elbows and the reduction of the pipe directly in front of this valve. Yeah? Here's a small features, function, benefits, where you can see this because of the latching device, the airflow you can change from 15 to 20 meters per second without putting the valve out of the lines. Yeah, could be changed in place. Yeah. So the time is too short.
And there are questions, Mr. Kammerer.
Okay.
Yeah, thank you, Guido, for the explanations. And yeah, I found or asked directly Mr. Hoffmann to open his mic and ask you, because he had one question about the pharmaceutical industry, and I will add to his question another question. What is about hygienic design, especially for pharmaceutical industry and for the nutrition industry? So, Mr. Hoffmann, please ask your question.
Okay. Hello, everybody. Do you hear me?
Yes.
All right. So I'm quite new to this topic anyway, but what I heard a lot of times is that everybody's talking about bar. Now I'm hearing 10 bar safety protection. What is the difference in these so-called 12 bar machines and vessels and 10 bars?
And so the connection was not so good for me. You have asked for 12 bar or 10 bar?
Oh, sorry.
It is correct.
What's the difference? Most of the time I hear.
So it's certified. It's certified for 12 bar. Yeah.
Oh boy.
Yeah, that was the main question. Was what is the difference between 10 bar safety and 12 bar safety? Because in the pharmaceutical industry, everybody talks about 12 bar.
Yeah, yeah.
For you, Guido.
Yeah, and because of that, it's certified for 12 bar. Yeah, and yes, your question, Jochen, about the pharmaceutical application. Yes, we can deliver this in different materials for sure, in stainless steel, in 304 and in 316, and stainless steel. Yeah, and also we have a zip version. Yeah. So that it could be designed with some zip nozzles inside that we can clean this in place. Yeah.
Okay, there's another question from Mr. Sario Jonas, and he asked a question. I think we heard it before. Do you have dust concentration limits for ATEX float valve? The valve looks sensitive for dust blocking.
Yeah, so we have no limitation on it anymore. Yeah, so the like I've said, the DEGRA have accepted that there is no limitation in the dust loading. The only point is from the process side, it makes sense or not. Yeah, for example, if you have a small pipe, yeah, in DN100, you have small gaps inside. You can still see my presentation?
Yes.
Yeah. Yeah. So if you have a DN100, yeah, so here this is a DN100 valve. Yeah. So and these gap, yeah, could be too small for your process. Yeah. So means maybe there are restrictions, some restrictions for your process, but not from the explosion protection side. The valve will close, yeah, independent of the dust loading you have, because we will cut it here. Yeah, if it's full of product, we will cut it. This is what we can demonstrate.
Okay, thanks, Guido. As the time is run out, I ask you just to have a look at the chat, and you will find some more questions, Guido. And please answer directly in the chat to those who had these questions. And as we talked previous about the isolation, exclusion isolation.